This video will continue our discussion of section 14.3. This is over double integrals, volumes, in 3 space. Okay, so it says find the volume below the surface. Okay, so we don't actually have a surface here, so it's going to be just a setup problem because they didn't give us an actual function, just a general one. Above the xy plane, bounded by, okay, we have these two things. I know that x squared plus y squared equals 4. Okay, I know that's a circle, so I'm going to go ahead and draw my axes. I can get these pretty good. 2, 1, 2, 1, 2, 1, 2. Okay, the first circle has a radius of 4, so or radius of 2, right? This is r squared, so r is 2. So I'll make the best circle I can do. There we go. I could have fixed it, but I can tell my axes are off. These are 2's. I'm just going to make them run into it. There we go. There we go. Okay, so those are 2's. And then the other one is not as obvious, but if we take x squared plus y squared and we minus the 2y over, we can complete the square to fix this. So I'm going to put a plus blank equals, and then the other side has a 0 plus blank. I take the middle number, the number coefficient of our linear term, or the coefficient of y or x, and I square it, or I cut it in half, rather, and then I square it. So that's -1 squared is 1. So that's what goes in here and here. As you can tell, if you look at it, this will factor to x squared, okay, plus y minus 1 squared equals 1. We force the factoring to happen. What that tells us is this is a circle shifted up 1 on the y-axis with a radius of 1, because that's r squared. So I'll put these dots, do my best to do a circle inside of here. All right, so we have this type of circle, and it says the region bound in quadrant 1 and by those circles. So we actually have this like crescent-looking shape right here. Right. So it's all of that shading. Sorry for the double shading there. I did it twice, so I do it there. It'll be darker again. All right, so we're trying to find the volume of whatever this function is over that region. All right, so we're going to do it in polar. We know first we start with our thetas. Well, theta, the first one is 0, right? Just goes out. And then the second one, it's all the way around to that first quarter, so it's pi over 2. R, this one is not as obvious, but we start here, go out that way. But sometimes when we're going spinning, we're going to be doing this, right? And eventually, we won't be down in here at all. We'll be starting on this other function here. Well, this other function is, well, okay, if I take that now, let's take this and put it in polar. I get r squared equals 2r sine theta. I just replaced y with r sine theta. Divide by r, and I get r 2 sine theta. That's that circle. That's the inner circle. The outer circle is going to be from the other equation, x squared plus y squared equals 4. That tells me that r squared equals 4, which tells me r is 2. So it's the inner circle first, so it's r2 sine theta, to the outer circle, which is r2. You can tell with these arrows, right? Inner circle to outer circle as we spin. Right? And then the function, we would just do f of r cosine theta, r sine theta. That means we just switched it over, times r dr d theta. I like these problems for tests because I really do. This is the hardest part, is coming up with those. The integral usually is just Calc 2 skills. So there may be a problem like this on your test. We're just set this up. All right, let's get another one. This one will have an actual surface. It says find the volume below. We have that bound by the region between above the xy plane. Okay, so let's try to get a shape here. I have x squared plus y squared. Taking that equation, minusing 2x. So let's put that here, minus 2x plus blank plus y squared equals, I minus that over, plus blank. Right? You take this one, you take -2, you divide by 2. I'm going to zoom in so I'll quit writing so big. Let me write this again. Forgive me for wasting a bit of time, but I'm like going through space too fast because I'm doing that. So I got x squared minus 2x plus blank plus y squared equals 0 plus blank. All I did was minus 2x to the other side and add blanks. What we do is we take this number, we divide it by 2, and we square it. It's going to be 1. This whole thing here that I just underlined, factors is the whole point of doing this, x minus 1 squared. Just factors to that, this old college algebra. This is a circle with a radius of 1, shifted right 1. So something like that. So we're trying to find the volume of the surface caught in here and the surface and the plane there. The flat XY plane caught between this. This is a, hopefully you can recognize that is a plane. So it's going to have some plane sticking through at some angle, and we're trying to find the volume captured between the plane I have underlined and the region on the XY plane that we have highlighted there. All right, so we need to change our regions. So the first thing I'm going to do is we need to solve for z. We're going to need that. That's going to be 12 minus 3x minus 4y. We also are going to have to put those in terms of polar. So r cosine theta minus 4r sine theta. That's z. All right, so we have that. That's good. And then we're going to need to take x squared plus y squared equals 2x. Convert this. Okay, so that's r squared on the left. And then on the right, we can replace x with 2r cosine theta. If I divide both sides by an r, I got 2 cosine theta. Okay. Now, what we're going to do is set up our volume. We have our thetas always on the outside. Now, this one, it is clear that it's cut off here and it's cut off here. There's nothing in between here that's going to get weird or anything. So we can just use the angles negative pi over 2 to pi over 2. We can just make it easy on ourselves. Instead of trying to figure out, well, we couldn't even cut. If you look into it and you consider all of them, it's not going to cut equally. So it really truly is these two angles. But there are some weird things happen. I'm not going to get too much into it. Let's continue on this one. So we have to go negative pi over 2 to pi over 2. That is, no, another way to think about it. This is what I was trying to say. Think about the tangent at this point. The tangent at this point is that straight up and down line. If I move anywhere, the tangent moves as well. So you could use that as that idea. If it's tangent to that, then you could use the angles. Okay, now we have our r's. So r, well, if I'm looking at it, I'm always starting here, and that's in the circle, so that's r equals 0. And then to get to the other side of the circle, right, that's that curve, which was the 2 cosine theta. Right, now I already have what I need for the surface. We've already converted it. And then we need I think we need an r. We can go ahead and, how about, no, let's put it here, r d theta. The r can be distributed. I'm just going to do it right here to save us some room. I'm okay with this. Some professors may not be. It's fine. You can save some writing if it's like something not little and you just need to think about it, because what you can do is just write down the next one. Okay, 0 equals negative pi over 2. So theta equals pi over 2. But now we can just think of the integral since it's already up there. All right, so we have r goes up by, it's already the first, goes up by 1. So it becomes a 2. Divide by the new one, so it becomes a 6r squared. You can think about derivatives going back. Minus r cubed. Take the derivative, it gets me back. Cosine wasn't affected because it was just r. And then minus, all right, we go r, raise it, we get 4 over 3 r to the third. Sine theta is not affected because it's was in respect with r. All right. Okay, we did that, but we have to run our bounds. It's r equals 0, r equals 2 cosine theta. So we have to plug all those in. One thing, that's a habit of mine. I actually try to leave off those bounds, and I'm like, oh, we have to do it with theta now, but we're going to end up with some r's, and I caught it. All right, so what we're going to do, I'm going to show you what that is plugged in. Okay, that is theta equals negative pi over 2, theta to pi over 2. If I plug all that stuff in, we get 24 cosine squared theta minus 8 cosine to the 4th theta minus 32 over 3 cosine 3 theta sine theta d theta. This would be a great thing to use a machine for, right? To use one of your calculators. When you plug it all, get all that worked out, you get 9 pi. If there is a way to do that, all of that by hand, it requires 2 integration by parts. I would recommend for this getting your hands on a calculator that can run those. TI-83s, TI-84s, those will do that if that's what you're using. If you need to borrow one of those, find out on campus where you can rent one. I think on Southeast campus, you can rent one from the tutoring center. From Northeast campus, you can do it at the testing center. I'm not sure about the other campuses, but I'm sure if you were to call one of the testing centers, they could point you in the right direction, or just borrow from a friend if you can do that. Also, Facebook Marketplace, just be careful where you meet them. Take somebody with you. Usually you can find TI-83s and 4s for like $20, $25 on there. People just get desperate to sell them because they just have no use for them after they finish their college algebra.